Hi everyone, my name is Greg Dahl. I'm a product manager with Juniper, focused on service provider cloud solutions. I started about 20 years ago working with operators in Europe deploying broadband, like France Telecom, Telecom Italia. And I've seen a few disruptions since then, like the migration from ATM to Ethernet, IPTV, fiber distributed in the access network. But I've never seen anything like we are seeing now in terms of transformation for service providers. And so what I would like to do with you today is look at the vision for the new network edge and how cloudification is going to be applied not just to the network architecture, but also to the operational model. Let's start by the market dynamics. About 4 years ago, there was a survey from GSMA. GSMA is a service provider association with the largest operators in the world. And they asked the CEOs of those companies, in the 5G era, how do you see your company? And only 10% said we're going to be connectivity providers. The rest, the remaining 90%, answered we're going to be either a digital service provider or we're going to be a platform provider. And so it's easy to see why they want to go in that direction based on the digitalization of enterprises and various trends in content and applications that's going on. Now, 4 years later, 3 months ago, GSMA started an initiative called the Operator Platform. And what they are doing is to make sure that the platforms that are being built by operators are consistent across each other. That common set of APIs can be used across operators so that a vertical service provider can build services across different operators using the slicing technology. The second big dynamic is for operators, customers, and partners to ask for near real-time control of their services. It's easy to see why SD-WAN has been so successful in a very small number of years, giving the enterprise the control from just a portal page, dynamically activate sites, ask for more resources, more bandwidth, more capacity, get reporting in real time. The third dynamic is really an operational transformation. It is leveraging automation and artificial intelligence to improve operations and optimize the cost of deploying and running the network. When you look at all those trends, it's easy to see that the network has to be prepared for the unknown. It requires a flexible and agile approach to apply cloud technology to the edge architecture and be ready to comply in real time with business requirements. So where do we start? Here is an example of access and edge architecture today, right? And you will have on the left side, you can see different types of accesses and typically fairly large equipments, chassis for broadband, for video, for business services. In some cases, very specific types of end users will get some kind of processing, value-added services like a virtual firewall, etc., in a centralized cloud. The content might also be in those centralized or regionalized POP. It's easy to operate, at least easier to operate. You power on the router, put the management IP address on the management port, and here you go, you can manage the device. Not that easy with the first implementations of NFV, for example. Now, when we move to the new architecture, we're going to have to make sure that we keep those properties for the architecture, performance, easy integration and operations, feature richness, expertise available. So the new requirements, as you can see, obviously, we're going to start distributing the service delivery point closer to the end user. Same for the content. We're going to leverage cloud technology and compute servers to bring this content and applications closer to the end user. We're going to leverage network slicing to basically give different profiles of service level agreements to different vertical service providers or end users. And since we are going to have slices from different sizes and shape, we want to have the flexibility to operate based on the scale-out model instead of scale-up. So we want probably to get smaller instances, smaller equipments, but that we can activate more dynamically. And dynamic is really the word here, since we have to automate the operations to match the dynamic business transactions that the business requirements will drive. The good news is that there is a very powerful toolbox that we have now, and it's called disaggregation. And typically today, the nodes are integrated. That means you get a hardware equipment that comes with an operating system and everything else that you need, including management. Sometimes the management layer extends to an external EMS that's tightly coupled with the network node. Now comes disaggregation, and it comes in mostly three flavors. The first one is a separation of the software and the hardware. NFV obviously is a perfect example, but more recently we've seen other initiatives, white box with open source network operating systems like Sonic. You can also plug third-party hardware devices inside equipment like SFPs that support PON for OLT functionalities. The second type of disaggregation is a functional disaggregation, and CUPS, control user plane separation, that's been there in packet core and is really central to the 5G core nowadays, is a good example of that. It applies also to the BNG. There is a new standard coming for BNG CUPS in this month in Broadband Forum. And the 5G core, you could look at the control plane, how it's architected based on microservices, and again, that's another form of functional disaggregation. The third dimension of disaggregation is management abstraction, being able to use data models in particular to use the same management software across different vendors, different access types, different equipments, and different use cases. So on the right, you have the example of how the new disaggregated edge could look like. You can see a mix of different hardware equipments and different functions, and even a distribution geographically across distributed sites versus centralized sites. Now, the benefits are pretty clear. As you can imagine, flexible distribution, independent scaling, for example, control plane versus user plane scaling, smaller functionality, so smaller blast radius in case of failure, easier fungibility of functionalities across different roles. But I'm sure when you looked at this diagram there on the right, you didn't think really about the benefits. You probably thought, oh no, this is so complex now because we have all these little color points and all these are going to be different functions that I have to deploy and upgrade and test separately. And it's going to be complex. And so really the challenge that we have to solve related to disaggregation is how do we make it practical and how do we operationalize and test the full stack of this disaggregation. So let's start by the connectivity aspects of re-architecting these smaller functionalities. And this is just an example here. What you see is you see services and you see service functions that are either delivered by physical nodes that we call service leaves here, or virtualized or containerized network functions in the edge cloud. What you see is those different equipments are going to be connected through a fabric. So we have access leaves and we have service leaves, and they're connected through a fabric with spine switches. And I would say, don't expect this is a 5-layer or 5-level class fabric, right? Obviously, those are distributed locations, space constraints. The throughput is a little bit more limited, so it's a smaller fabric, obviously. Then you have overlays, and those overlays provide flexibility and dynamic behaviors. And what you will notice in this picture is both physical network functions and virtualized or software-based network functions use the same connectivity model. All right, so let's look a bit at the properties and requirements for this new network. So we just saw the fabric. The second thing is we need a telco cloud that's optimized for the edge. So for example, you will want to have remote compute support to avoid the overhead coming from cloud management on site. The third area is the dynamic access and subscriber steering. So basically to be able to map and stitch the customer traffic to the proper slice and the proper service instance across leaves and network functions. Last but not least, automated day 0, day 1, day 2 operations for this very large distributed number of components. So let's focus on that for now. And yeah, I know this slide is a little bit of an eye chart, quite a lot of information to absorb. So operations, traditionally, you would use CLI. This is not possible with this large number of objects in the disaggregated architecture. On the other hand, what you can do is you can pre-templatize the network infrastructure. And I would like you to think a little bit differently here. So think of your network infrastructure as a distributed running software. Think of your network operations as a software development process. This kind of approach is called network infrastructure as code. What it's going to enable is to manage the network and its artifacts like configurations and software versions and automate how we manage them. It relies on a version controlling system like GitLab and CI/CD pipelines to automate validation and deployment. And there are three key components that are really specific to networking. There is a test engine, a zero-touch provisioning engine, and a monitoring engine. And this monitoring engine can be combined with the provisioning engine to provide a closed feedback loop. On this slide, we have a few examples of use cases that are enabled by this automation and this network infrastructure as a code model. I'll give you an example with the software upgrades. So imagine on the left side, you have this new Junos release that you want to distribute across all your sites. And Juniper provides this new release. It gets basically put on the repository that's owned by the service provider. The versioning control system detects that this is a new version. And so it has to go through a testing pipeline, based on the positive results, either automatically or with manual confirmation. The new software release is activated in all the network. So this process between getting the new software release and deploying it in all the network can actually take as little as a few hours. And if you're familiar with upgrade cycles, let's say on a BNG inside the whole country, this process, can take several months. So this is really huge benefit in terms of operations. So now we have this new architecture. We have a new cloud native operational model. What are going to be the use cases that benefit from this? Well, first, obviously, new generation of business services. After all, 5G is all about new services to the enterprise and to the vertical segments. So think about slicing, virtual applications, virtual security, and down the road, edge computing. Second, for subscriber services, they will also benefit from cloudification. You look at the Broadband Forum project called Cloud Central Office or Cloud CO. It includes a full re-architecture based on software-defined access node or virtual OLT, the distributed BNG or BNG cups, where the control plane of the BNG can be containerized while the user plane can be on a high-performance ASIC-based platform. And the cloud-based architecture makes it easier for operators to share the infrastructure. So there is this FANS use case, fixed access network sharing, that is also very powerful. The third one is actually to share across different types of accesses, fixed and mobile. And initially, it might be just sharing a cloud or sharing an infrastructure, transport, for example. But initially, the goal is to be able to share the same 5G core across any access, including wireline. This is a project that's really important to me. I lead this effort at Broadband Forum. There is a group called Wireless Wireline Convergence that works together with 3GPP. And we are releasing or planning to release standards and specifications this month. The group has been working hard. I'm very proud of all the team there. On the cable side, very similar use cases. If you look at the distributed access architecture or DAA, it's very similar to Cloud CO. And Cable Labs is also working on 5G convergence based on an AGF. As you can see, Juniper is bringing microservices, scale-out, and cloud-native operations to the network edge. It does that both for virtual and physical equipment. And the key building block is network CI/CD. As much as disaggregation is a great tool, it might include and bring with it a lot of complexity, but we're mitigating that thanks to network infrastructure as code model. And we can automate the full stack, hardware, software, services, and applications, the full lifecycle management of it. We have a demo for this, so I will encourage you to look at it. It's really good. And this is it. I hope you found this interesting. I hope that you will remember this is not just an architecture evolution. It's really about trying to reach the state of evolutionary architecture that can cope with change. And I would love to hear back from you and discuss your edge and access transformation plans or points of views. And I hope we meet in person. But in any case, see you soon.